Math 13 students, welcome. We have material here for section 5.1, probability distributions for discrete random variables. You'll need your calculator. In fact, you're going to need your calculator for pretty much everything from here on out. So let's hope you got it. Let me go ahead and share my screen and we'll get going. All right, 5.1. Discrete probability distributions. We have some worked examples. A little bit of an outline. I'll review definitions. We'll calculate parameters using your calculator. We'll identify significant outcomes. And as we do all of this, we will include appropriate examples. I'll remind people that a random variable, usually x, has a single numeric value determined by chance for each outcome of the procedure. You can think of rolls of the dice. If you want a nice example, you might roll a 1, a 2, a 3, and so on and so forth. Those are the numeric values. Those are the outcomes. A probability distribution is a graph, a table, or a formula that will give you the probability for each value of the random variable. So the probability distribution would give you the probability of rolling a 1 or the probability of rolling a 2 and so on and so forth. In this section, we look at discrete random variables. Now, a discrete variable can take on a finite number of values or a countable number of values or outcomes. It's important to realize the word countable there is a fancy math word, to be honest. You really want to focus on the notion of a finite number of values. There's only certain outcomes that are possible. Much of what we do in Chapter 5 focuses on the number of successes when conducting a trial or a number of trials. So the number of successes would be things like x equals 0 or 1 or 2 or 3. So those kind of numbers, those are your discrete values. There are requirements. Every probability distribution has 2 requirements. If I sum up all the probabilities, it must equal 1 or unity, as we like to say in the math world. Also, each probability has to fall between 0 on the low end and 1 on the high end, inclusive. It can be 0, it can be 1, it can be anything in between. It can't be bigger than 1, it can't be smaller than 0. That won't fly. They're not probabilities here. Now, let's talk about the parameters. A probability distribution has parameters, just like a population. There is a mean, mu, a standard deviation, sigma, and a variance, sigma squared. You'll note the Greek notation that is common for items when we talk about parameters of a population. I've included the formulas here because this is what our calculator will be using, and you've already encountered them in the PowerPoint presentation and in the text. But here we're going to have our calculator use them. We won't use them directly. Here's our first example. We have a probability distribution. We're making random guesses on a 4-question multiple choice exam. Each question has 3 possible choices, and our random variable x is the number of correct guesses that we might possibly make, anywhere from 0 on the low end to 4 on the high end. There's the probability distribution. You can see we've got those probabilities there. If I come over here to my calculator, let's see, we have 0.198 plus 0.395 plus 0.296 plus 0.099 plus 0.012. Add those all up. Look at that, we get 1. All right, so that's hopeful. I also note something about those numbers, the probabilities themselves. They are all at least 0 or larger, at least 1 or smaller. So first thing I always like to do is to check the requirements for a probability distribution to make sure they're satisfied. That's what we just did. So we saw that the sum of those probabilities was equal to 1, and we also observed that all those probabilities fell within the appropriate range. Now, we want to find the parameters, the mean, the standard deviation, and the variance. This is where we're going to need our calculator. So if I come over here to my calculator, stat, I need to get that probability distribution into my calculator. So I'll select edit, and I'm here at my lists. A lot of times I've got to clear out lists to make room for new data. I highlight the list name, I hit clear, followed by enter. Again, I highlight the list name, you got to get the cursor into the list name, then you can hit clear, followed by enter. So, and now I can place those values for X in list 1 and the probability of X in list 2. I get 0, 1, 2, 3, and 4, and then I want to come over here and list the probabilities. Do you remember what they are? I don't. All right, so if I come back over here, we have 0.198. We said 0.198. 0.395. 0.296. 0.099. 0.012. So all those probabilities are now in there. We'll use the one variable stat command again. That is over on your second drop-down menu. It's the first item there. Just hit select. And you're going to need to point your calculator at the correct data. And I'll remind you that you'll hit the second key first, list 1, and then we need to include a comma right up above the 7. Without the comma, my calculator can't handle multiple lists. Second, list 2. So I got list 1 and list 2 in there. Then I can go ahead and hit enter. And there I see the mean. I'll notice that S is empty, but I do have a sigma, the standard deviation. And I'll remind you, down below we have Q1, Q2, Q3, and the minimum and maximum, all that good stuff. The 5-number summary is down there. I'm interested in the mean, the standard deviation, and the variance. So my X values here have no decimal places at all. So using our rounding rule for summary statistics, I'll take one more than my data, the X's. So I'll take one decimal place for each of these numbers. So if I come back over here, the parameters are, we have a mean of 1.3 correct answers every time I go through this guessing process. My standard deviation to one decimal place, 0.9 correct answers. Now, before I get to the variance, I want to point something out. If I come back over here to my calculator, take the 0.9 and square it, I get a value that rounds to 0.8. Now, here's the issue. That number there is probably incorrect. What I need to do is to use the unrounded standard deviation, all those decimal places. It's not as hard as it seems. Your calculator already knows the standard deviation. You just ask Mr. Calculator to go find it. And he's very proud of the fact he still knows. Here's how we use it. On your calculator, find your vars key. I notice that we are in statistics. I notice option number 4 is the standard deviation sigma. So I can select that, square that, and hit enter. And now you'll notice I get a 0.89 and change. That changes the value that I might choose to use. So coming back over here to my my presentation, we have a variance of 0.9 correct squared. Remember, the units for variance are got to be squared. It leads to some oddities like this. I have no idea what a correct squared answer is, but we deal with it anyway. So let's talk now about significant outcomes and parameters. Significant or unusual outcomes are associated, at least in this section, with either an unusually high number of successes or an unusually low number of successes, which I guess means a high number of failure. A little bit more about the notion here of significant low and high outcomes. They are defined as outcomes that are at least 2 standard deviations away from the mean. 2 standard deviations on the high side, 2 standards on the low side. You've seen this picture before in a previous presentation, I believe. Significantly low values, mu minus 2 sigma and south. Significantly high values, mu plus 2 sigma up to the north. Here's example number 2. Using that data that we just utilized, would it be unusual to get 3 correct? Would that be an unusually high number of successes? Remember, we didn't study, we made random guesses on this. Then we're going to ask the same question about 4 correct guesses. We want to explain this in 1 to 2 complete sentences, so we'll take a look at the structure there also. I used the mu and sigma I've developed up above. So we've got 1.3 plus or minus 2 times a 0.9. On the low end, we have a negative 0.5. A little odd because you can't have a negative number of correct guesses. 0 is the minimum. But it's an artifact of the calculation. 3.1 on the high side. So 3.1 and higher correct guesses are going to be unusually high. So anything at least 3.1 or higher is considered significantly high. So x equals 3 is not a significantly high number. But what about 4? Since 4 is greater than 3.1, 4 correct is truly a significantly high number. Honestly, if you guessed and you got 4 correct, I really wonder how much guessing you did. I bet you were really tapping into some subconscious knowledge. We also like to bring the notion of probability into this. Usually we try to identify unusual outcomes via a probability or probabilistic type of argument. Now, a significantly high number of successes in this context occurs when the probability of x, the number of successes, is less than a 0.5. That means x is somewhere close to n. You got lots of successes for a significantly high number of successes. On the other hand, a significantly low number of successes also occurs when the probability is less than a 0.5. Here, your x's are going to be down close to 0. Little success, lots of failure. And again, I'm going to point this out. Lots of success, unusual. Very, very little success, also unusual. Here's example number 3. More random guessing, this time on a 25-question multiple choice exam. We have A through E possibilities for each of those questions. I've already done the calculation for us, so we can take a look at the probability. The probability of guessing at least 12 correctly is a 0.0015. So, would guessing correctly at least 12 times be an unusually high number of successes? Explain, if you would, please, in 1 to 2 complete sentences. And I will be asking you to do something similar on your quizzes and exams. There's our question again. Yes, because first I note that the probability of 0.0015 is less than the benchmark, if you will, of 0.05. That means that at least 12 correct is a significantly high number of correct guesses. This is an unusual outcome. And that is down to where the probability falls, below 0.05. Where does that 0.05 number come from? It's kind of a people number. You encountered it when you looked at the empirical rule way back in chapter 3. Plus or minus 2 standard deviations on one of those bell-shaped curves, well, that's 5% for the tails. So, we've taken a look at some basic definitions and reviewed those. You calculated the parameters. I've showed you how to do that on your calculator using your lists. We've identified significant outcomes 2 distinctly different ways. mu plus or minus 2 standard deviations, give you some values to look at, or the probability of a set of outcomes being less than a 0.05. And we've seen appropriate examples as we played our way through this little garden of discrete probability distributions. That brings me to the end of the presentation. I will stop the sharing. I will ask that you go away now and study this. Take a good look at the video. Make sure you read the text and view the PowerPoints. And please do reach out with questions and concerns. Bye-bye for now.